Next topic that we're going to look at is solving exponential equation using logarithms. In 10.2, we solve the exponential equations which can be rewrite both sides of equation into the same base with a single exponential term. That is, notice that a to the x power equal to a to the y power. So in this sessions, we're not going to be, a lot of exponential equation, you cannot rewrite it into the same base. For example, 2 to the x is equal to 5. I cannot rewrite this into the same base on both sides of equations. So what we need to do is we need to use the logarithms to help us solve these type of problem. Okay, so in 10.2 we use this idea, right? If the exponential equation can be rewriting as the same base, then we can use the property if the exponentials on both sides have the same base, then it's logically to say that the exponent must be equal to each other. So we use that idea. Now, for this type of example, right, the exponential equations, we need we need to use logarithm, which is cannot rewrite into the same base. So those type of problem. So that's the difference between the first type and the second types. So if you cannot rewrite into the same base, then what you do is you take logarithms to both sides of equations. So by doing that, what's going to happen is it will allow us to use one of the properties from the logarithm, which is log of base a m to the c power. And we want this c power to become in a base level. So from the exponent level, we can bring it down to base level. And from there on, we can solve. So that's what we want to look at, okay, in this. So let's review a little bit. So for this first example, notice that I can rewrite the left-hand side into one single exponential, because if you have the same base and multiplying, you are adding the exponent together. So x to the second power plus x equal to, on the right hand side, 4 happen to be able to write into base 2, so 2 will be 2 to the second power. So this is the type of equations that can be rewritten into the same base. If we can do that according to the property, if you have the same base and equal, that means exponent must be equal to each other, which allow us to solve this quadratic equations by subtracting 2 on both sides, factoring it, and then using zero factor property, I can say that x plus 2 is equal to 0, x minus 1 equal to 0, which give us two answers, negative 2 and 1. Since exponential equations have no restriction, so I have two answers in this case. Now, let's continue to the next example. So notice that this example 2 is pretty straightforward one that I'm giving to you so that you can see the difference. 7 to the x power is equal to 4. And notice that I cannot rewrite 4 in terms of base 7, nor 7 in terms of base 4. So how do we solve this x variable which is in the level of exponent level, right? So what we need to do now is take the logarithms on both sides, and I will particularly use log of either base 10 or log of base e, because those are the two logarithm functions that I can use my calculator to do the approximations. So this type of problem, we want the exact answer and approximation answer. So I will point it out later on what does it mean by that. Right? So I'm gonna take, I personally like to use logarithm ln, right? Logarithm with base e. So I take, let me use it in different color so that you can see it better. So I basically use take ln on the left hand side and ln on the right hand side, which is this now become ln of 7 to the x power, that is equal to ln of 4. Now, according to the properties of logarithms, I can bring the exponent of the argument, in this case, which is x on the left hand side, to the base level as a factor. So it will be x times ln of 7 is equal to ln of 4. Remember, ln of 7 and ln of 4 are a number, so you treat them like a number. If I want to solve for x, I basically divide both sides by the ln of 7, which is the number. If you use the calculator, this ln of 7 is a number. So now I got x is equal to ln of 4 divided by ln of 7. You need to remember this ln of 4 is a number and ln of 7 is a number. Okay, together. So this is what I mean by exact value. If I want to do the approximations, that's where I'm going to use to compute this ln of 4 divided by ln of 7. So make sure you have your calculator, okay, and you know how to use the calculator to get the right answer. So it'll be 4 ln of 4 divided by ln of 7. So that gives me approximately 0.7124. Dot, dot, dot. Okay. So double check ln of 4 divided by ln of 7, and that will be 0.7. So take a look at our next example. So in this example, same thing, right? I cannot rewrite 18 as base e, but however, first thing that you need to do is always have a single exponential by itself. That means I need to get rid of this factor 2. So divide both sides by 2. So e to the x minus 2 is equal to 9. Now we're going to take the ln on both sides. So ln of both sides, because that's the only way that we can, bring down this exponent x minus 2. So from the logarithm property, now I can bring down this x minus 2, the exponent, as a base level, times with ln of e equal to ln of 9. We know that from the properties ln of e is equal to 1, so it will be x minus 2 times 1, that is equal to ln of 9. So basically, when I distributed 1, that will be x minus 2 is equal to 9. So therefore, my x is equal to ln of 9 plus 2. This is my exact value. And now we're going to approximate it. My x is approximately. So on the test, I may ask you both of them, right? So 9 ln, and then you add 2 to it, plus 2. So that gives me approximately 4.19722 dot dot dot. Let's take a look at the next example. So I already have the one exponential on one side, left hand side, and the other side there's a number, and then we know that 2 cannot be rewritten as base 5, or 5 cannot be rewritten as base 2. So now our only choice left is take logarithm on both sides. So I take ln on both sides. So that will become ln of 2 to the x plus 4 power equal to ln of 5. Using the properties of logarithms, I can bring down, I can write the exponent of the argument as a factor on the left hand side. So that means the exponent of argument 2, x plus 4 as a factor, so it will be x plus 4 times 2 equal to ln of 5. Now, solving this, remember that this ln of 2 is a number, So I'm going to distribute it, this number into both of the terms. So that will become x times ln of 2 plus 4 times ln of 2 is equal to ln of 5. To solve for x, so first I'm going to have to subtract 4 ln of 2 to both sides. So ln of 5 minus 4 ln of 2. And finally, I divide both sides by ln of 2. So that will become x is equal to ln of 5 minus 4 ln of 2 divided by ln of 2. So you can simplify a little bit like before. So I can say ln of 5 over ln of 2 minus 4 ln of 2 over ln of 2, which is ln of 5 over ln of 2 minus 4. So this is my exact value. Sometimes in multiple choice tests, they leave the answer right here. This is all the way to simplify the form. So either one is okay for me on the test, and you can always check by, do the approximations. So let's compute ln of 5, right? 5 ln, and then divide by 2 ln, and then take away 4, which is negative approximately 1.678 dot dot dot. So make sure you try with your calculator to get this same answer. That way you will know that you'll be able to compute correctly on the test. So moving on to next example right here. So similarly, I cannot rewrite into the same base. So the next step that I'm gonna do is checking exponential term alone on each side it is. So I can take ln. So ln, take the logarithms on both sides. So 3x minus 2 equal to ln of 4 to the x power. Now using the properties of logarithms, I'm going to rewrite the exponent of the argument as a factor. So that means x minus 2 times ln of 3 is equal to x times ln of 4. Now, remember that ln of 3 is a number, so I'm going to distribute that into both of the terms. That's give me x times ln of 3 minus 2 times ln of 3. That is equal to x times ln of 4. I have x on multiple terms, so that means I'm going to have to move all the terms that has variable x to one side of the equation. So meanings I'm going to subtract x ln of 3 to both sides. So that's give me x ln of 4 minus x ln of 3. And then I will factor out the greatest common factor x. So this will become x times ln of 4 minus ln of 3. And finally, I can divide both sides by this binomial, which is negative 2 ln of 3 divided by ln of 4 minus ln of 3. And this is my exact value. Okay? And approximations will become this. So x is approximately, now use a calculator to compute that. Right? So make sure you use your calculator correctly, because all the parentheses must be put it properly so that you will get the right answer. Okay, so this is how I will put it in my calculator. I will put open parentheses and close parentheses on my numerator, and then divided by open parentheses denominator and then close parentheses. So that will help me to get a correct answer. So times with negative 2 ln of 3, okay, divided by open parentheses, ln of 4 minus ln of 3, ln of 4 minus ln of 3, and this gives me approximately negative, oh, wrong color, negative 7.6376 dot dot dot. And in the next video lecture, we're going to talk about the compounded interest.